Hi, this is Dr. Goldstein, and today I will be discussing L'Hopital's rule. So first, recall all of our different indeterminate limit forms. A limit is indeterminate if it has form 0 over 0, or infinity over infinity, 0 times infinity, infinity minus infinity, 0 to the 0 power, 1 to the infinity, infinity to the 0, or 1 over 0. L'Hopital's rule deals specifically with indeterminate limit forms 0 over 0 or infinity over infinity. So it states, if you have functions f and g that are differentiable for values of x near c, and if the derivative of g is not 0 for those values of x near c, then if this limit as x goes to c of f of x divided by g of x is of either of these two indeterminate forms, either 0 over 0 or infinity over infinity, then when you want to compute this limit of this ratio, it will be the same as the limit of the derivatives. And notice we are not using the quotient rule here. What L'Hopital's rule says is the limit as x approaches c of f of x divided by g of x is the same as the limit as x approaches c of the derivative of f divided by the derivative of g. Now this is true as long as the second limit exists or is finite, either positive infinity or negative infinity. And we can take this limit at a finite value c, but it's also true if x is going to infinity or negative infinity. Again, as long as f and g are differentiable for values of x, let's say near positive and negative infinity, so meaning suitably large, either positive or negative values of x. And again, we need the derivative to be non-zero for those values. Okay, so this boxed statement in red is the statement of L'Hopital's rule, and it applies again to these two limit forms, 0 over 0 or infinity over infinity. So let's see this demonstrated with a few examples. So let's look at the limit as x goes to 2 of e to the 2x minus 4 minus 1 divided by x squared minus 4. Now, if we try to evaluate this limit, we get e to the 2 times 2 minus 4 minus 1 divided by 2 squared minus 4. So simplifying, we have e to the 0 minus 1 divided by 4 minus 4. So in the numerator, we have 1 minus 1. In the denominator, we already see that we have 0. And so in the numerator, we also have a 0, and this limit is of the form 0 over 0. And so we can apply L'Hopital's rule. When we do that, remember what L'Hopital's rule says is this limit is equal to the limit as x goes to 2 of the derivatives. So on the top of this equation, we have e to the 2x minus 4 minus 1. And when we take the derivative of that, we get 2 e to the 2x minus 4, where that 2 comes from the chain rule applied to 2x minus 4. Now in the denominator, the derivative of x squared minus 4 is just 2x. And now, when I evaluate this limit, I get 2 times e to the 4 minus 4 divided by 2 times 2. And now, when I simplify, I have 2 times e to the 0 divided by 4. I just get 2/4, which I then simplify to 1/2. So remember, in the statement of L'Hopital's rule, we needed to know that the limit of the derivatives exists before we can conclude that the original limit is the same. And in this case, that's not a problem. The limit of the derivatives is equal to 1/2, And so now we know that our original limit is equal to 1/2 as well. So we have the limit as x goes to 2 of e to the 2x minus 4 minus 1 divided by x squared minus 4. This is equal to 1/2. Fabulous. Let's look at another problem. So let's say we look at the limit as x goes to infinity of e to the 3x divided by x squared minus 3x plus 1. So in the numerator, we have e raised to a very large power, which is going to be a very big number. And in the denominator, we have a degree 2 polynomial. So if we look at the leading term, if we just look at that x squared, that's going to take over. So in the denominator, we also just get infinity. So again, this is one of the forms where we can use L'Hopital's rule. And so we apply it. Our original limit is equal to the limit as x goes to infinity of the derivative of the top is 3 times e to the 3x, and the derivative of the bottom is 2x minus 3. Now, when I evaluate this limit, I still have a problem, because in the numerator, I still get infinity, and in the denominator, I also get infinity. But remember, L'Hopital's rule applies to this type of limit. So again, we can use L'Hopital. And so now this second limit must be equal to the limit of its derivatives. So in the numerator, we get 3 times 3e to the 3x, and in the denominator, we just get a 2. And so here, if we simplify, we have the limit as x goes to infinity of 9e to the 3x divided by 2. And here, if we evaluate this limit, we have 9 times infinity, so just infinity divided by 2, which is infinite. So if we think back, this limit is equal to infinity. Remember, L'Hopital's rule applies when the limit either exists or is equal to infinity. So our third limit is equal to infinity, so is equal to the second limit. So now the second limit is equal to infinity, and so it has to be equal to the first limit. And so what we conclude after 2 applications of L'Hopital's rule is that the limit as x goes to infinity of e to the 3x divided by x squared minus 3x plus 1 is equal to infinity. One thing that I'd like to call your attention to is that it is not true that, for example, e to the 3x divided by x squared minus 3x plus 1 is equal to 3 e to the 3x divided by 2x minus 3. This is ridiculous, right? I can't just take the derivative of the top and the bottom and set that equal to my original function. So it is not true that these are equal. What L'Hopital's rule says is that the limits are equal. So, when you're working on a problem and using L'Hopital's rule, you must write your limits. That is absolutely non-negotiable. It is also good form when using L'Hopital's rule to indicate that that is what you are using. So typically, we write a little L'H to go with the equal sign when we are using L'Hopital's rule, in order for your reader to be able to say, oh, we are not equating these two functions. We're using this powerful theorem that equates the limits. The last thing to remember with L'Hopital's rule is, again, it only applies to these two specific limit forms. So your last reminder is that L'Hopital's rule is only for limits of the form 0 over 0 and infinity over infinity, and do not use it otherwise.